Hi everyone. This videos is part of a series on Spring Framework certification by Everyone Can Code community. In this video, we've explored some of the most important questions for a technical interview all about Spring. We hope that this video will help you in your upcoming Spring interview. If you like this video, don't forget to like and subscribe in Everyone Can Code YouTube channel. Good luck. So, Spring is the most broadly used framework for the development of Java Enterprise Edition applications. The core features of Spring can be used in developing any Java application. We can use its extensions for building various web applications on top of the Java EE platform, or we may just use its dependency injection provisions in simple standalone applications. So first, what is the purpose of Spring Inversion of Control container? The Spring Inversion of Control container is responsible for 1. Creating the objects. 2. Configuring the objects. 3. Managing dependency between objects with dependency injection. 4. Wiring the objects together, managing complete lifecycle of objects. Okay, what is the main benefit of inversion of control principle? 1. Inversion of control principle is the base of Spring framework. It supports dependency injection in an application. With dependency injection, a programmer has to write minimal code. It also makes easier to test an application. 2. Most important benefit is that it leads to loose coupling within objects. With loose coupling, it is easier to change the application with new requirements. So, does inversion of control containers support eager instantiation or lazy loading of beans? Inversion of control container in Spring supports both the approaches, eager instantiation as well as lazy loading of beans. Then, what are the benefits of application context in Spring? Okay, application context in Spring provides following benefits. 1. BeanFactory methods. These are used to access application components. 2. Load file resources. It helps in loading file resources in a generic fashion. 3. Publish events. It enables publishing events to registered listeners. 4. Internationalization support. Ability to resolve messages to support internationalization. 5. Parent context. Ability to inherit from a parent context. So, how will you implement application context in Spring framework? Application context in Spring can be implemented in one of the following 3 ways. 1. File system XML application context. If we want to load the definitions of beans from an XML file, then file system XML application context is used. The full path of XML bin configuration file is provided to the constructor. 2. Class path XML application context. To load the definitions of beans from an XML file in the class path, we use class path XML application context. It is used for application context embedded in jars. 3. Web XML application context. To provide configuration for a web application, web XML application context is used. While the application is running, it is read-only. But it can be reloaded if underlying application supports it. Oh, explain the difference between application context and BeanFactory in Spring? Okay, main differences between application context and BeanFactory are 1. Automatic bin post-processor registration. BeanFactory does not support bin post-processor registration, whereas application context support this. 2. Automatic BeanFactory post-processor registration. BeanFactory also does not allow automatic BeanFactory post-processor registration, whereas application context allows this. 3. Message source access. BeanFactory is not convenient for message source access. Application context is quite convenient for message source access. 4. Application event. We cannot publish application event with BeanFactory. But application context provides ability to publish application event. So, between application context and BeanFactory, which one is preferable to use in Spring? Okay, Spring documentation recommends using application context in almost all the cases. Application context has all the functionality of BeanFactory. Then, what are the main components of a typical Spring-based application? In a Spring-based application, main components are 1. Spring configuration XML file. This is used to configure Spring application. 2. API interfaces. Definition of API interfaces for functions provided by application. 3. Implementation. Application code with implementation of APIs. 4. Aspects. Spring aspects implemented by application. 5. Client. Application at client side that is used for accessing functions. Okay, explain dependency injection concept in Spring Framework. So, dependency injection is a software design pattern. It is used to implement inversion of control in Spring Framework. As per this pattern, we do not create objects in an application by calling new. Rather, we describe how an object should be created. In this way, creation of an object is not tightly coupled with another object. A container is responsible for creating and wiring the objects. The container can call injecting code and wire the objects as per the configuration at runtime. So, what are the different roles in dependency injection? Okay, there are 4 roles in dependency injection. 1. Service objects to be used. 2. Client object that depends on the service. 3. Interface that defines how client uses services. 4. Injector responsible for constructing services and injecting them into client. Spring Framework provides what kinds of dependency injection mechanism? Spring Framework provides 2 types of dependency injection mechanism. 1. Constructor-based dependency injection. Spring container can invoke a class constructor with a number of arguments. This represents a dependency on other class. 2. Setter-based dependency injection. Spring container can call setter method on a bean after creating it with a no-argument constructor or no-argument static factory method to instantiate another bean. So, in Spring Framework, which dependency injection is better? Constructor-based or setter-based? Okay, Spring Framework provides support for both constructor-based and setter-based dependency injection. There are different scenarios in which these options can be used. It is recommended to use constructor-based DI for mandatory dependencies, whereas setter-based DI is used for optional dependencies. Everyone can code YouTube channel. Okay, what are the advantages of dependency injection? Dependency injection pattern has following advantages. 1. Dependency injection reduces coupling between a class and its dependencies. 2. With dependency injection, we can do concurrent or independent software development. 2 teams can work parallel on classes that will be used by each other. 3. In dependency injection, the client can be configured in multiple ways. It needs to just work with the given interface. Rest of the implementation can be changed and configured for different features. 4. Dependency injection is also used to export a system's configuration details into configuration files. So we can configure same application run in different environments based on configuration. For example, run in test environment, UAT environment, and production environment. 5. Dependency injection applications provide more ease and flexibility of testing. These can be tested in isolation in unit test. 6. Dependency injection isolates client from the impact of design and implementation changes. Therefore, it promotes reusability, testability and maintainability. What are the disadvantages of dependency injection? Dependency injection pattern has following disadvantages. 1. Most of the time dependency injection forces developers to use an injection framework like Spring. This causes dependency on a framework. 2. With dependency injection, clients are dependent on the configuration data. This becomes extra task for developers when the application does not need so many custom configuration values. 3. Code is difficult to trace and read in dependency injection. It separates behavior from construction of objects. 4. Dependency injection increases complexity in the linkages between classes. It may become harder to manage such complexity outside the implementation of a class. So, what is a Spring Bean? 1. A Spring Bean is a plain old Java object that is created and managed by a Spring container. 2. There can be more than one bean in a Spring application. But all these beans are instantiated and assembled by Spring container. 3. Developer provides configuration metadata to Spring container for creating and managing the lifecycle of Spring Bean. 4. In general, a Spring Bean is singleton. Evert Bean has an attribute named singleton. If its value is true, then Bean is a singleton. If its value is false, then Bean is a prototype Bean. By default, the value of this attribute is true. Therefore, by default, all the beans in Spring Framework are singleton in nature. Finally, what does the definition of a Spring Bean contain? Okay, a Spring Bean definition contains configuration metadata for bean. This configuration metadata is used by Spring container to 1. Create the bean. 2. Manage its life cycle. 3. Resolve its dependencies. So finally, thanks for watching. If you enjoyed the video, like, subscribe. Everyone Can Code YouTube channel.